field. Okay. Later, one more method is there. We have to eliminate the local attraction by using a angles. Okay, by using a angles to the with respect to bearings. Okay. Before that, solving up to that problem, we have to discuss about the calculation of angles from the bearings. Okay, before going to the solving up the second problem, okay, or second method, we have to discuss about the how to calculate the angles from the bearings. Okay, just observe this figure or this image. Okay, the title shows that it is calculation of the angles from the bearings. Means they'll give the bearings with respect to fore bearing and back bearing, or both fore bearings are there depending upon the lines. By using these two lines with respect to bearings, we have to calculate the angle. Angle means what? It is the angle between the two line. Okay, so just observe here this one. Okay, first example. Here you have to observe that one. This is station A. There are two lines are there, that is AB and BC, AC. Okay, so this is our north directions. So if you consider the whatever the measurement of a bearing in the system of whole circle bearing, so you have to take the from the bearings from the with respect to north direction only. So that is, for example, for this AB line, the bearing is θ1. Suppose this one is θ2 for the second line AC. So here the angle between these two lines, that is AB and BC, that is considered as that is alpha here. Okay, we have to calculate the alpha here by using these two bearings, that is θ1 and θ2. Maybe it will be fore bearings, or maybe it will be fore bearing and back bearings. Okay, so how will calculate alpha here? Very simple. We'll get the alpha is equal to, the bigger one is θ2, smaller one is θ1. The same station is there. The with respect to these two bearings, the north direction is same. Okay, so θ2 minus of θ1, we are getting this much of angle. Okay, clear? So by using the bearings, you have to calculate the with respect to angle between these two lines. So we can write alpha is equal to θ2 minus of θ1. Okay, this one is simple. You are directly calculating the alpha here. Coming to this one, second picture. Okay, so here there are two lines are there. There are two different stations. That is, one is A station, one more it is B stations. This is AB one line and BC is the one line. Okay, so here θ1 is the fore bearing of the AB. Clear? Then θ2 is the fore bearing of the BC here. So they have given only θ1 and θ2. Then you have to calculate the angle between these two lines, that is alpha here. Clear? So here, just you have to observe here the extension up to this line. Okay, like that dotted line. The whatever the angle of this is there, that is you can consider as a θ1. Clear? So it is not necessary to consider this θ1. Instead of that one, you know the bearing of the AB line, that is θ1, that is fore bearing of this one. So you can calculate the back bearing of this line, that is AB line, from here to here angle, that is back bearing of AB line. So how you to calculate? There is a formula is there. Back bearing is equal to fore bearing plus or minus 180 degree. Here observe here θ1 is lesser than the 90 degree, or sorry 180 degree. So you can use the directly for calculation of back bearing, it is plus 180 degree. So back bearing of AB is equal to θ1 plus 180 degree. We'll get the back bearing of AB line from here to up to this line. If you know that this bearing, already we know the θ2 here up to this line. The difference of these two bearing, okay, that is back bearing of AB minus of fore bearing of BC. We'll get this much of angle. That angle is called as a angle between these two lines AB and BC, that is alpha. So formula you can write like this: alpha is equal to 180 plus theta 1 minus theta 2. Okay. Likewise, we have to calculate the angle in between the line if there are two lines are in two different stations. Okay. Similarly, this one, the whatever only one stations are there, then again same theta 1 and theta 2 are there with respect to lines. So you have to calculate the angle between these two lines. So you can directly that alpha is equal to, you can write theta 2 minus of theta 1. Coming to this here just observe here, they have measured the two bearings, that is theta 1 and theta 2, okay, from the north. By observe that one, the measurement of a theta 1 and theta 2, it is in terms of quadrantal bearing systems. So that is theta 1, it is north to east side. For theta 2 is north to west side. So for calculation of alpha, that is angle between these two AB and BC line, AB line, AC line, that is alpha is equal to, directly you can write theta 1 plus theta 2 if it is in the condition of quadrantal bearing. Clear? Then similarly, this one, again this is also in terms of quadrantal bearing system. So we have to calculate the alpha here. This is theta 1 and theta 2. So the whole angle is 180 degree. In 180 degree, the difference of the 180 minus of theta 1 and theta 2 will get the alpha value. So I have written here, that is alpha is equal to 180 minus of theta 1 plus, in bracket of theta 1 plus theta 2. Okay. Likewise, last one, that is alpha is equal to 180 minus of theta 1 minus theta 2. Okay. Likewise, we have to calculate the angles from the bearings. Okay. The same method I am using while solving the problem of the local attraction. Okay, this is the second method. I think it is clear now. Okay, I'll go to the slides now for the second problem. Example, second one. The following bearings were measured in running a closed traverse. Okay, I will explain what is the meaning of closed traverse in later. Okay, so they have given these lines, and these are the four bearings, and these are the back bearings. Okay, so determine the correct magnetic bearing of a line. Whatever the previous method is, you can also solve this problem. But here I am solving this problem by using a second method. Second method means you have to calculate the correct bearings from the angles. Okay. So as you know that first step is both are same for the difference of the fore bearing and back bearings. Okay. So again same, first step, difference of the fore bearing and back bearing, we are getting the 179 degree 15 minutes difference of the AB line, fore bearing and back bearing. Similarly, second line BC, we are getting the 182 degree 15 minutes. Then CD line, it is show that it is 341 degree 45 minutes minus of 161 degree 35 minutes. We are getting the 180 degree 10 minutes. Similarly, next one, again we are getting the other than 180, it is difference of these two bearing, we are getting the 180 degree 45 minutes. Just observe here, your difference between with respect to bearings in the first one we are considering the higher value, and next second one is the lowest value. Okay, don't consider like that back bearing minus of fore bearing or fore bearing of minus back bearing. Okay, then again we are getting the other than the 180 degree. Just observe here, the first four lines, any line, it is not equal to the 180 degree. So that means what? all the lines are affected by the local attraction because it is not equal to the 180 degree. So we have come to the last line, that is EA. Again, difference of this one, we are getting the 179 degree 40 minutes. So in this survey line, the no one line is not equal to the 180 degree after the difference of the back bearing and forward bearing. Then in that condition, how to solve the problem is we have to go with the corrected bearings by using a angular method or by calculating the bearings, corrected bearings from the angles. Okay. So in that condition, what we have to do, just observe here, by the inspection of the above difference of the forward bearing and back bearing. Okay. In that, no one line is exactly equal to the 180 degree. So our step is next, you have to observe the lowest difference of the with respect to value of 180 degree. Okay, nearest value to the 180 degree. So just observe here, it is not nearest to the 180 degree. If it is difference of the 180 degree of this angle, this bearing, we are getting the 45 minutes. This one is 2 degree. This one is 45 minutes again. And this one is 1 degree, more than 1 degree, or 20 minutes. So in that all the lines, this one, this is our 1 minute. Okay, just observe this bearing. It is very nearest to the all the 5 lines to the 180 degree. So our CD line, the forward bearing of CD and back bearing of the CD line, it is differ by the 180 degree 10 minutes. It is very nearest to the 180 degree in these 5 lines. So the difference of the 180 degree and 180 degree 10 minutes, we are getting the difference is equal to the plus 10 minutes. That 10 minutes is divided into 2 parts, that is 5 minutes and 5 minutes. We have to add and subtract with respect to forward bearing and back bearing of the CD line. What we have to do, after difference of this difference bearing of the CD line, that is 180 degree 10 minutes minus of 180 degree, we are getting the difference is 10 minutes. That is, we are considering the plus. Now this error, okay, that is 10 minutes, you have to distribute into 2 parts for the forward bearing of the CD and back bearing of the CD. With respect to bearings, we have to add this half of this error to the one of the bearing and subtract the same half of that error to the with respect to forward bearing or back bearing. Okay, you can add that 5 minutes to this bearing or this bearing, or you can subtract the forward bearing or back bearing of the CD line. Just remember that if you add the forward bearing of the CD line, so you have to remaining error will be subtract in our back bearing of the CD line. Okay. So what we have to do? So our corrected forward bearing of CD is equal to, I am here considering the half of that error. I am adding the forward bearing of the CD and the remaining half of the error subtracting with respect to back bearing of CD. So here correct forward bearing of CD is equal to 161 degree 35 minutes plus 5 minutes. That is equal to, we are getting the 161 degree 40 minutes. Similarly, we can calculate by using that error back bearing of CD. That is correct back bearing of CD is equal to 341 degree 45 minutes minus of 5 minutes. That is equal to 341 degree 40 minutes. Okay. So these are the two corrected bearings of the CD line. The difference of these two bearings, you are getting the 180 degree 0 minutes. After the distributing the error with respect to fore bearing and back bearing, you are getting the difference is 180 degree. Clear? So next we have to calculate the angles by using a given fore bearing and back bearing lines. Okay. In this problem, they have told that it is a closed traverse. Closed traverse means the whatever the lines are there, that is A, B, B, C, and are there. These are the lines are the whatever starting point is there end with the same point only. That surveying is called as a closed traverse. Just it is a circuit form. Okay. So these are the four bearings of the all the lines here. Okay, that is 71 degree 5 minutes, 110 degree 20 minutes, 161 degree 35 minutes, and with respect to fore bearing of the with respect to lines I am written here in this figure. Okay. Now we have to calculate the angle A, angle B, and angle C. Okay, we have to calculate these included angles. Okay, angle A, B, C, D, E. Okay, so first start with the angle ABC. Okay, so angle ABC at this station there are two bearings are there. One is fore bearing of BC, one more is back bearing of BA. That is this one, and this two. The difference of this one, we are getting this much of angle here. Okay, so angle ABC is equal to 250 degree 20 minutes minus of 110 degree 20 minutes, that is equal to 140 degree 0 minutes. Similarly, angle BCD, again at this station we are calculating the angle C. So fore bearing of CD, back bearing of CB, these two. Okay, so 292 degree 35 minutes and 1 minus of 161 degree 35 minutes, you are getting the 131 degree 0 minutes. Next, angle CD, again same procedure for difference of these two fore bearing and back bearings. Similarly, next angle E. So difference of these two, we are getting the exterior angle. Okay, this much from here to here, because this is back bearing and this one is the fore bearing of the EA line. So if you are difference of these fore bearing and back bearing, we are getting the 260 degree 45 minutes. This is exterior angle of the ED line and EA line. That is this one. This is our exterior angle. So for calculating this much of angle, that is included angle, so it is calculated by total circumference one circle minus of this exterior angle, that is 360 degree minus of 260 degree 45 minutes. We are getting the interior angle is 99 degree 15 minutes. Then last angle EAB, that is difference of the 71 degree 121 degree 10 minutes and 71 degree 5 minutes. We are getting the 50 degree 5 minutes. As you know that if it is a closed traverse, so the total included angle of this closed traverse is how much it is. Okay, but adding up these calculated angles, we are getting the 541 degree 15 minutes. But in the theoretical form, there is one formula is there for calculation of the included angle, that is 2n minus 4 bracket into 90 degree. Here n is meaning is, the meaning of the n is number of sides. Here there are 5 sides are there. Okay, put up the 5 here in the n place. We are getting the 2 into 5 10, 10 minus 4 6, 6 into 90 degree. we are getting the 540 degree. Okay, so means the whatever the calculated angles are, these are incorrect. Okay, so now we have to calculate what is the how much error is in the with respect to total included angle. That is, error is equal to observed angles, that is 541 degree 15 minutes, minus of calculated, that is theoretical included angle, that is 540 degree. That is equal to difference of these two, we are getting the 1 degree 15 minutes. So these error we have to distribute the with respect to angles in terms of 5 categories. That is, divide into this error into five parts because of 5 angles are there. So correction for the each angle is minus 15 minutes because our error is, you are getting the getted here, it is positive. So our correction will be always opposite of the error sign convention. That is 15 minus 15 minutes. So this minus 15 minutes you have to deduct in the all the calculated angles. So go to the next step. The angle ABC, your calculated angle is 140 degree 0 minutes. Our correction is minus 15 minutes. We are getting the angle ABC is equal to 139 degree 45 minutes. Similarly, BCD 131 degree 0 minutes minus of 15 minutes. We are getting the 130 degree 45 minutes. Similarly, angle CDE, we are getting the 120 degree 40 minutes. Similarly, angle E, that is 99 degree 0 minutes. Then last angle A is equal to 49 degree 50 minutes. Okay. Now we have to check the again whether these angles are equal to the 540 degree or not. So add them. We are getting the exactly equal to the 540 degree 0 minutes. Now you can use the calculation of the corrected forebearing and back bearing of the these one for the by using these corrected angles. Clear? So coming to the last step, corrected forebearing of DE. Start with the DE because of we are C and D are the we are adjusted the with respect to error. So start with the forebearing of DE is equal to 341 degree 40 minutes minus of the with respect to station angle. Okay, just I will show it with respect to picture. 1 minute. Okay, this is our picture. So start with the forebearing of DE. Here, just observe here. This is our forebearing of DE. Okay, from here to here. Sorry, actually it is okay. Forebearing of DE. Okay, that is 220 degree 50 minutes. Okay, similarly this one. Okay, so sorry. Okay, this is our observed forebearing of the DE line. Now we already know that what is the back bearing of this DC line, that is 341 degree 40 minutes. So I will make it okay from here to here. This is our back bearing of DC line. So for this is our back bearing, that is how much it is, 341 degree 40 minutes. We already calculated the angle D here. If you deduct this angle with respect to back bearing of DC line, we'll get the this much of angle. Yes, that is equal to the forebearing of DE. So back bearing of DC minus of angle D will get the correct forebearing of DE line, that is 221 degree 0 minutes. Just observe here, our observed forebearing of D is 220 degree 50 minutes, but our corrected forebearing of D line is 221 degree 0 minutes. Similarly, calculate the back bearing of DE. We are already get the corrected forebearing of DE. So easily you can calculate for difference of the 180 plus or minus of the 180 degree. So back bearing of D is equal to 221 degree 0 minutes. This one minus of 180 degree. Here minus sign used for the forebearing is greater than the 180 degree. So difference of this one will get the 41 degree 0 minutes. Similarly, next line, that is forebearing of EA. Actually here calculated is, observed is 300 degree 50 minutes. Clear? So here the forebearing of the EA line from here to here. Okay. So you know that. So this is our forebearing of the EA line. Here we already know that back bearing of the ED line is this much of angle. It is 41 degree. Okay. So in that one, with respect to exterior angle, already we know that one. Okay. So difference of this one will get the, actually it is positive. Okay. So adding up these bearings will get the 302 degree 0 minutes. Clear? Actually this is exterior angle from here to here. We are already just before we are calculated. This is our exterior angle and this is back bearing of the ED line, that is 41 degree. Okay. Adding up these two bearings will get the 302 degree 0 minutes. Similarly, back bearing of EA line. Okay. Already we get the corrected forebearing. The minus of 180 degree will get the back bearing of the EA line. Next, go to the forebearing of AB. Forebearing of AB 122 degree 0 minutes minus of 49 degree 50 minutes. 122 degree means what? It is the back bearing of EA line minus of this much of included angle, that is 49 degree 50 minutes, will get the forebearing of the AB line, that is 72 degree 10 minutes. Actually our measured bearing is 71 degree 5 minutes. It is incorrect. Okay, this one is the correct forebearing of AB. So you can easily calculate back bearing of AB is equal to forebearing of AB plus 180 degree, or you can use the back bearing of the next line, that is 128 degree, that is equal to 252 degree 10 minutes. You can use any formula. Okay. So similar last, I think forebearing of BC is equal to difference of the with respect to back bearing minus of with respect to included angle of the this angle B. So this is our back bearing minus of this one, will get the forebearing of the this BC line. So 252 degree 10 minutes minus of 139 degree 45 minutes, that is equal to 112 degree 25 minutes. Then back bearing of BC is equal to, you can add minus deduct the minus 180 degree, actually it is plus sign. Okay, this is plus, we'll get the 292 degree 25 minutes. The plus sign because of this forebearing is lesser than the 180 degree. Then last, forebearing of CD is equal to with respect to back bearing of the at that stations minus of with respect to angle C. Difference of this one will get the 161 degree 40 minutes. This one we can use the check, because Before that one, initially we have calculated the this much of angle by using a distributing the error, that is 5 minutes and 5 minutes minus of the 5 minutes of the measured this one. Okay, so this one will act as a check. Okay, in the first step only we have calculated the or distributing the plus 5 minutes to the fore bearing minus 5 minutes to the back bearing of the CD line. Okay, these are the steps to follow the for eliminating the local attraction by using a second method, that is calculation of corrected bearings from the angles. Okay, there are number of steps are there. Okay, very simple, but you have to observe the draw the with respect to diagram and calculate the angles. Okay, then later we can easily calculate the corrected fore bearing of the and back bearing of the all the lines. Okay, the same problem is asked in the last year final year examinations. Okay, any doubts in this problem? Any doubts? Adirilpa? Any doubts? Okay, shall I continue?
Yes, sir.
Okay. Once again, I am requesting here, please write your roll number in the chat box. The same thing I am considering the attendance for the today's class. Okay, already some people are written here. Okay, the who have joined the later. Okay, after the start of the class. So write your rule number. Okay, especially rule number in the chat box. Don't write only name or USN. Write your roll number only. Okay, so I'll continue the class with the class. Okay, so slides are visible now. Next one is traverse surveying. Okay, this is the second part of the your second model. Okay, a small part of theory is there. Again, here also there are number of problems are there depending upon the problems. Okay, so start with that one. First, you have to understand the what is the meaning of traversing. Traversing is the type of the surveying in which number of series of connected survey lines are. It is form a one framework. These lines are measured with the by using a directions and length of the with respect to line. That direction means what? Maybe it will be angles or bearings, and measurement length of measurement of a length by using a chain or tape instrument. Okay, traversing means what? It is the type of the survey in which a number of connected survey lines form this framework and the directions and length of the survey lines are measured with the help of the angle and or direction or and tape or chain respectively. Okay, so traversing means what? It is a series of connected lines. We have to measure the length of the with respect to lines as well as a directions of the with respect to lines. That surveying is called as a traverse surveying. In this traverse surveying, there are two types are there. One is closed traverse. One more it is open traverse. Start with the closed traverse. When the lines form a circuit which ends at the starting point, it is known as closed traverse. Okay, suppose you are going to the survey work. Okay, this is our starting point. If you start here like this, AB, BC, CD, DE, and again you have end with the surveying work at the same point, then it is form a one closed formwork, okay, or framework. This type of traversing is called as a closed traverse. Okay, for example of this closed traverse, we can consider the boundary of the city or boundaries of the lakes, woods. Woods means it is forest. Okay, okay, generally we are considering these are the example for the closed traverse. We can use the previous figure. Okay, the whatever this figure is there, this is also same. The whatever starting point is there, A, B, B, C, C, D, and D, and again EA, it is closing at the starting point of the line. So this is also one of the example of the closed traverse. Then coming to the open traverse, if the circuit ends elsewhere, it is said to be an open traverse. Okay, it is not in this traversing. The whatever starting point is there, the end point will be ends at a elsewhere, just maybe away from the starting point. This type of traversing is called as a open traverse. Example of this open traverse, we can consider the road line. Okay, for example, if you start with the road line, if you consider the Gandhi Chowk to the ashram, if your starting point of the survey line is Gandhi Chowk, end point is the somewhere around the our ashram, then what will happen? The starting point and end point, these are the two different points. This is example is for the open traverse. Also you can consider the canal line. Okay, you can consider the example for the open traverse, that is canal line. Okay, so you can use this is the one of the figure for the open traverse. Just observe that this is PQ, QR, and maybe it will be RS is the maybe will be here. Okay, this one is the example of the open traverse.